Hello and welcome to the Android N game development course by Pack Publishing. My name is James Said and I've been developing games for Android using the Android SDK and Libgdx for over 6 years now and produced a highly successful How to Make a 2D Game series on YouTube, spanning well over 50 videos which involves creating desktop, iOS and Android games using Libgdx. I've also published 2 games on the Google Play Store amassing thousands of downloads. The Android SDK is extremely powerful with creating games, despite what people may think, especially with new APIs introduced in Android N, such as VR and Vulkan. We'll also be using Libgdx, which is an open source cross-platform game development library that supports Android. It makes game development a lot easier and includes a slew of extra features. In this course, we will be going through both libraries to make a simple game. This course contains 7 sections. In the first section, we will simply be installing all the necessary tools needed for development and have a basic project setup that we can run and work from. Additionally, we'll also go through the ins and outs of Android Studio. In the second section, we will look at how an Android app works and runs from the ground up, along with looking at the development process of a basic Android app. In the third section, we will use the Android N SDK to learn the basics of creating a simple game and covering concepts such as a game loop, rendering graphics, and receiving user input. In the fourth section, we will be adding some flair to our basic game in order to give it some depth and personality by implementing animations and sensor input. In the fifth section, we will move on from the core Android SDK and use the knowledge obtained until this point to further develop our game using Libgdx. In the sixth section, we'll go through how to interact with our player and the real world with Libgdx. By the end of this course, we will look at using Libgdx to create 3D games by introducing the 3D engine and importing models from Blender. By the end of this course, you'll be able to set up your own template Android or Libgdx project to be imported into Android Studio, and then go on forth to create a basic Android game, a basic 2D Libgdx game, or even a basic 3D Libgdx game. For this course, you will need a basic computer setup, but nothing too powerful is required. You will also require a good amount of patience as bugs and errors are a given in programming. This course is aimed for intermediate Java programmers who are comfortable with the Java programming language and may or may not have ever used the Android SDK before. Welcome to Section 1, Enter the Studio. In this section we're going to be focusing on 4 primary topics. The first being setting up and installing the JDK, Android Studio and the Android SDK. Then I'm going to give you a tour of the Android Studio. Then we're going to set up a basic project and I'm going to go through with you the main core files, and then we're going to run our basic app on both a physical device and an Android virtual device. In this video we're going to go through the setup and installation of the various tools we're going to be using in our development environment for our Android N game. We're going to take a look at the installation of the JDK on Windows, Mac and Linux, and the joint installation of the Android SDK and the Android Studio, and setting up our Android virtual machine, and also installing the Android build tools and anything else associated with the Android SDK within Android Studio. So first things first, you're going to want to open up your web browser and point it to the URL oracle.com/technetwork/java/javasc. Once you're on that page, hit the downloads button. Once again, download. And the version at the time of recording is 8U101, and that's probably going to be different by the time you watch this video. However, the basic layout of the download page should be the same. Go ahead and accept the license agreement and download the version of the JDK that's appropriate for your operating system. So I'm using a 64-bit version of Windows, so I will be downloading that. Once it's finished downloading, open up the installer and just go through the installation as usual. There's nothing here that we need to customize, so just keep hitting next and you should be okay. Once that's finished, we can then go ahead and install the Android SDK and Studio. Nowadays, the Android SDK and Android Studio come bundled into one installer. And you can find this at developer.android.com/studio. Once you're on that page, go ahead and click the download button, which will automatically detect whatever operating system you're using. Scroll down and accept the terms and conditions, and hit download. Now it's a pretty large download, so you are going to have to give it some time. Once you've finally downloaded that 1.2 gig file, go ahead and open it, hit next, and it'll prompt you to install the Android SDK, which of course we're going to do, but then also it's going to ask if you want the Android virtual device. This is essentially the Android emulator. It's the emulator for an Android phone. As you can see, it's recommended, and I personally am going to install it. but some people like to not install it and save that 1 gig because they like to use their physical Android phone to test their app instead. Now I do have my physical Android phone as well, however I like to use the emulator in case I'm quite a lazy person, so in case my phone's across the room and I don't want to have to go and get it and then plug it in, so then I can just use the inbuilt emulator on my computer. Hit next. Agree. I'm just going to let it install to the default locations. Next. And install. Now this is going to take quite a bit of time. I know it looks like it's going quite fast now, but once it gets to about here it takes some time. So just leave it be for a while and then come back to it. Once it's finished, we can go ahead and click next and start Android Studio. Once it's open, we're not going to go ahead and start a new Android Studio project. Instead, we're going to go ahead into Configure, click SDK Manager, and as you can see here, we have a few tabs. The first tab, we have SDK Platforms. We have all the different number versions of Android, and as you can see, we have Android 7 and 6 partially installed. We're going to fully install Android 7, we'll leave 6 as it is, and then in the next video, we're going to talk about all these other different versions. Next tab is the SDK tools, and as you can see, there's some updates available for the Android SDK build tools, the Android SDK platform tools, the Android SDK tools, and the Android support repository. We need to make sure that these are on the latest versions just so that we run into as little issues as possible, obviously. And finally, we're going to need the Google USB WebDriver for later when we test our app on a physical device. Hit apply, OK. Attempt to install all packages, accept the license agreement for them all, hit next, and just give that a few minutes. Well, that took as long as the installation of Android Studio itself. So hit finish, and that's pretty much it. Hit OK, and we're done for today. In the next video, we'll go ahead and dive into a huge tour of the Android Studio, and also talk about the different Android versions as I mentioned earlier. In the previous video, we went ahead and set up and installed the JDK, the Android SDK, and Android Studio. In this video, we're going to talk about Android Studio. However, we're also going to delve a lot into how Android and its SDK works in terms of versioning. So we're going to look at a run-through of the Android SDK versioning system, and what API levels are, and talk about minimum SDK levels, what's new in Android 7.0 and what we can take advantage of, and a brief tour of Android Studio ready for the next video. When you create your Android project, there's a file called the manifest, which we'll go into a lot more detail once we actually get to that point. But there's a few important lines called users SDK, and there's 3 main parts to it. The minimum SDK version, the target SDK version, and the max SDK version. So the minimum SDK version designates the minimum version of Android that your app can run on. The target SDK version is the version you are designing for. So, for example, with Android 4, Google introduced the Holo API. And so if my target version was Android 4, then I'd be focused on Holo, as you can see briefly mentioned here. But if I'm targeting for Android 5, then I'd be focusing on material design. And the max SDK version is just simply the maximum version of Android that your app can run on without breaking. So Pokemon Go, for example, when that first came out, it didn't run on Android 7. So they had to set the max SDK version to Android 6. And simply put, each Android version has its own API level number. Even the little updates get their own number. And this is how you're going to specify when you actually do come around to developing your Android game. Google has quite a bit on this page in regards to development considerations when talking about the API level at this link right here. So Android 7 has a multitude of new features, a lot of which are just for users, but quite a lot which affect developers as well. For example, multi-window. It won't affect us in game development, so we won't have to worry about that. However, Vulkan is one of the things that is key to Android 7 game development, and we will talk about Vulkan at a later date. And again, the same thing with virtual reality. With Google Daydream coming out very soon, developers are jumping on the Android VR bandwagon. With the battery life improvements, battery life is less of a concern for us as game developers. Notification direct reply can also be useful even in game development. Data saver can also be useful, considering we will be sending requests to a server if we're going to make a multiplayer game. My personal favourite, seamless security updates. A more to the point list of features can be found in this Wikipedia page. So for a lot of people, the main factor into deciding which API level they're going to target is the distribution of each platform. And this handy little chart can be found at this web address. Now, it is slightly outdated. The last collected date was September 5th, 2016, which was roughly around the time which Android N was released. And at that time, the distribution wasn't high enough for Google to actually record. As you can see here, it says any version with less than 0.1 distributions are not shown. So at this point, it's assumed, I mean, this was nearly a month ago, so at this point, it's assumed that Android N distribution is roughly around 0.1%. The great thing is that we can still target Marshmallow and above, knowing that 20% of our user base is still going to be there. Hell, most people are on the Lollipop and above with nearly about 50%, so that's pretty decent. And also if you consider the amount of people in third world countries probably on these older versions as well. Okay, so enough of the boring stuff. Finally, I'm going to give you a brief tour of the user interface of Android Studio. You don't have to open it yourself or worry about creating a project. I've just created this test project just for the time being, just to show you what's in Android Studio before you actually go in and dive in yourself and get sort of, overwhelmed by just the sheer amount of stuff that you'll see on your screen. So okay, let's just collapse this. So over here, you have your Project Explorer, and over here, you have where you write your code. It's plain and simple, it's just split it into two, and you can resize it here. I'm just going to make this a bit smaller. If I then open up app, I've got 3 folders: manifests, Java, and res. You can work out what they pretty much mean. I mentioned the manifest earlier. If I open this up, the only thing in there is the Android manifest, and that's the manifest I was speaking about earlier. If I open up Java, then this is where all my source code is. And for res, this is where all my resources are. It's very well organized. Up here are all pretty much my action buttons. I'm not gonna lie to you, you won't be using many of these apart from play. And yeah, that's about it. We will use the AVD manager soon. Apart from that, there's not much there. If we go over to the left side, even further than this little Project Explorer, there is quite a bit. If we click on structure, there's nothing really there. There we go. What structure does, it just shows you the file that you have open, and then all the methods and the variables within. You might have seen something like this in Eclipse, so it's nothing really new or exclusive to Android Studio. If anything ever disappears from the sides here, so as you can see, the Project Explorer has just disappeared. All it is a little click. That's it. And this sort of code editor window, that's never ever going to disappear. And as you can see here at the top, that's a nice little handy navigation as to where you are at. It's a bit slow, but it's there nonetheless. If we go up to the top here, there's again nothing much that we're going to be using. So I urge you not to be overwhelmed here. The only thing that I think we will be going into is, if I can even find it, it was under file settings the whole time. These things always elude me. First thing I'm going to do actually is go into editor and go into colors and fonts. Go into font, yeah. And I need to make a new scheme because I can't overwrite the default. And I'm just going to change the font size, something a little bit more manageable, just so you guys can see even better. Yeah, I think that's good. But yeah, that's where that is. If you do want to change your font, that is where it is. You know what? I'm going to increase it even more. So that is where that is. And also, another thing we're going to do is, if you see right here, we're going to right click and click show line numbers, just so you can follow along better as I go on with this series. In the next video, we're finally going to create a project and actually start writing a bit of code, so you should be very much excited for that. In the previous video, I gave you a tour of the Android Studio and how the Android SDK API level system works. We're finally going to set up a project in Android Studio. I'm going to take you through the basic project setup, and then once we've done that, I'm going to go through all the main file types and what they do. So open up Android Studio, and you should have this familiar menu that we've seen before. And go ahead and start a new Android Studio project. We're just going to call our application game. And the next thing is the company domain. This is the domain of your company. I don't know why I just rearranged those words as an explanation. So for example, my website is www.evh98.com, so my domain is evh98.com. What this does is, it just takes that, reverses it, and then puts your application name, and that forms a package name. If you've worked with Java projects before, or hell, any programming projects before, you'll be familiar with what a package name is, and you can manually override this by clicking on that edit button there, changing it yourself, and then hitting done. We're not going to include C++ support for now, but if you want to use Vulkan, then I would go ahead and do that, but not today. Project location, just so the compilation times are as low as possible. So for example, I'm going to put my project, the default location is on my M.2 SSD drive, as opposed to putting it on my standard hard drive. It's not going to take up much space, so I'm not that concerned. Hit next. And here's the minimum SDK we were talking about in the last video. And Google have a handy little help me choose here. Unlike before where we just had a separate distribution, this gives you a cumulative distribution. So I think personally, and it also gives you a nice little API rundown here, I think personally we should go for KitKat. And remember, this is just the minimum, okay? This is just the minimum required for our device, for our app to actually run. So we're going to go ahead and go with KitKat. And we are not going to be using Android Wear, and we're not going to be using Android TV. You can, if you want. By all means, you know, use notifications with Android Wear, have your game run on Android TV, not a problem. I'm just not going to go through that. I'm surprised they still have Google Glass though, wow. API 19, so that was like, yeah, KitKat. Wow, some time ago. Next thing is an activity. We're going to go through activities more in depth later on, but a brief sort of explanation would be, it's basically like a screen, a section of your app. So for example, in Facebook Messenger, the main screen, the list of contacts and that you have and list of recent messages, that would be one activity. Then an actual conversation with someone would be a different activity. We are basically going to write our own activity, so it doesn't really matter what we pick here. This is probably more representative of what we're actually going to be using, but for now we're just going to stick with an empty activity just so we have something to start with, and then we'll, you know, write our own. Hit next, leave this as it is, we don't really need to change any of that, and hit finish. Give it some time, Android Studio is slow. Once it's opened up, go ahead and open up the project little section. And we're going to just go through each file one by one. So we'll uncollapse this and head over into manifest. I've mentioned the Android manifest before. So the Android manifest is an XML file. Now, for those of you who don't know, XML is a markup language, just like HTML. Unlike HTML, though, it doesn't really do anything. You know, it doesn't actually, I really don't know how to describe this, but it's more of just an information language. It's more of a language that just goes, okay, here's some information. Take it. Think of it as a read-only language, really. Like I said, just doesn't do anything. So the Android XML just has the main sort of information of your app. So for example, things like, am I going to allow system backups? So Android has a feature where you can back up the app and its data locally. And this is true. It tells the app where the icon's located, what it's going to be called when it's in the app drawer. I don't know what RTL is actually, yeah, I don't know. The theme of the app, which we're going to speak about in a minute, and then all your activities are here. This is also where permissions would go, so things like, am I allowed to access the internet, microphone, you know, just things like that. Apart from that, there's not really much in the manifest. Now, if we uncollapse this Java here, we'll see 3 different folders. it's our package name, but duplicated 3 times. Now, these 2 folders, we don't need to worry about. They're nothing to do with us. Well, I mean, they are, but this is all stuff that Android Studio takes care of. I actually don't know why they even show us it. We don't need to be shown this, really. They should stay hidden, I'm not gonna lie. But anyways, collapse this, uncollapse this, and we have a main activity. This is just our main class, essentially. This is Android's version of a main class. As you can see, it says main activity. You've got an onCreate method. It's just all sort of there, really. Now, if we go into res, this is where things get a little bit interesting. This drawable folder is where you're going to put your game assets. So obviously, there's nothing in there yet. Now, this layout, if you noticed, while we were actually setting up a project and we were creating our main activity, it made a layout that matches, or sorry, that's not the right word. They made a layout for us that links to the main activity. If we open this up, and I'm going to make this a bit bigger. If we open this up, we get a little, how do I say this, designer sort of thing. Actually, first thing I'm going to do is change this from the Nexus 4 to my phone, the Nexus 6P, Pixel C? What's that? Oh, that's the laptop, isn't it? Anyways, where is it? Nexus 6P. There we go, that's my phone. Okay. And this is essentially what our app currently looks like. What Android does is, a main activity gets created, then the content view is set to R, which is resources, .layout, activity main, which is this XML file, which, as we know, XML just feeds this information of the layout to the main activity, which then renders this. As you can see, we can drag and drop widgets here, but since we're making a game, that's not really what we're going to be doing. But it is nice to have a look at the text view of this as well. If I click there, it will show you that that's the text view here, and that's where the text is coming from. It's all pretty self-explanatory, I'm not going to lie to you. But like I said, since we're going to be making a game, we're not really going to be looking into these layouts that much, but it's still good to know. The next thing is this mipmap folder. That's quite a new thing recently. If we open that up, we have this iclauncher.png. And now you might think, okay, PNG is meant to be an image. Why is this a folder? It's 5 images, as you can see if you uncollapse this, with little brackets. Now, back in my day, or back when I first started doing Android development, there were only 3 of these. There was LDPI, MDPI, and HDPI. Low density pixels, low density pixel? Yeah, I think that's just what it is. DPI is density pixels, isn't it? Low density pixel, medium, high, and that was it. Eventually, XHDPI came out, then double XHDPI, now we're on triple HDPI. Why didn't they just make QHDPI and then UHDPI? Why did they do this? I will never know. I don't think they were expecting screen resolutions to get that high. Bit foolish of them, but anyways. And if you remember back into the Android manifest, this does look a bit familiar. If we go back here, we go into this icon, it references at mipmap, here, IC launcher, which is our icon. And yeah, that's about it. Anything that's going to go in there apart from the launcher icon. And finally, we have this values folder. And the first thing that you see is colors. You say, oh, okay, interesting, just a list of colors. Why? Why is this? And why do they have names for them? Well, for those of you that are observant, you'll notice that these colors are a bit familiar. Well, if we go back to activity main, they're these colors. That's the primary, and that's the primary dark, as you can see here. And we have our accent as well, but we haven't got any buttons for it to... Yeah. We haven't got any widgets that make use of the accent color, so... But where are these coming from? If we go into activity main, even in the XML, it's not there. If we go into the main activity, it's not there. So where is this actually feeding into? Well, this is all being referenced by the styles file, which again is an XML file. And again, it's the same thing. You're specifying the primary color and you're just linking back to the color sheet. But again, where is this going? Well, again, if you've been observant, you'll notice this app theme is familiar. Let's go back to the Android manifest. And the theme of the whole app comes from there. So any new activity I make, I don't have to specify in here. It's just going to automatically take the theme of the app. But again, because we're making a game, we're not going to be using much of this, but it's still good to have a knowledge. We're not going to be touching dimensions.xml. We don't really need to. The final thing, small thing, is strings.xml. And this is just a global, well, there's only one thing here, but this is where you can put your global variables for strings. There's only one string here, and that's the app name, that's game. If I change this to test, go back to activity main XML, it changes. End of story, really. Nothing new there. If I go back to main activity, I can just close all of this. And that's pretty much it. Hopefully I didn't go too fast, but I think I did get a little bit excited. But nonetheless, we're actually going to be running that little, hello world sort of demo. Well, not demo, but that hello world layout that we saw. We're actually going to be running that in the next video on both a virtual machine and a physical device. In the previous video, we set up a project and we went through the basic file structure of an Android project and what each file does. In this video, we're actually going to run our Android application. So how we're going to go about this is we're going to set up an Android N virtual device through the AVD manager in Android Studio, then set up the drivers for a physical Android device, and how we would go about running the app on both of these separate devices. So in Android Studio, go ahead and click on this little button up here at the top with the purple phone and a little Android head, and that'll bring you to the AVD manager, and I'll prompt you to create a virtual device. So we're going to go ahead and do that. You're given a range of devices here. In an idealistic testing world, you're going to want one of each, well, not one of each, but like you're going to want a good range. So I'd probably have a Nexus 4, 720p 4.7 inches, Nexus 5X 1080p 5.2 inches, and a Nexus 6P 5.7 inches at 2K. That's a good range of devices for me to test my app. For now, I'm just going to go with the Nexus 4, just because it's small and manageable, just for, the purposes of this series. I'm going to hit next, and of course we want Android N, and I'm going to go with a 64-bit image. Next, and you can go into advanced settings. There's nothing really in there that you should change. There is one thing I want to change though, RAM. I don't think 1.5 gigs is quite enough. I'm just going to bump that up to 2 gigs. Just because I have 8 gigs on my computer, so I may as well. Everything else should be fine. Hit finish. You don't need to change the name. And there you go, you have your Android virtual device. Now let's move on to a physical device. So in your web browser, you're going to want to head on to this page, developer.android.com/studio/run/OEM USB HTML. On here, this is where it will go through how to install the drivers. If you're on Mac OS X or Linux, you don't actually need to install a driver. If you're using a Nexus phone, then we actually already downloaded the drivers for this. In Android Studio, if we go to Tools, Android SDK Manager, head on over to SDK Tools, there you can see we have already installed the Google USB driver. Other OEMs, click on this, and you get a table for all of the OEM drivers that are available. If you scroll back up to the top, you can then go ahead and follow the instructions on this page to install drivers for your phone on your operating system. On your Android device, go ahead and go into Settings, About Phone, and then under the build number, click on that 7 times, hit back, go into Developer Options, and enable USB debugging. Your physical device is now ready for testing. Now to run our app, go ahead and click the play button up here, and it will prompt you to either open up a virtual device or use one of your connected devices. For now, I'm just going to use a virtual device so that I can actually show you guys. It'll go ahead and launch the Android emulator. This might take a bit of time. And as you can see, our app is now launching automatically. And there you go, you have your game, Hello World. If you happen to exit out of that or whatever, then you can simply just find it again in the app drawer, as if it was an actual phone, and launch it once again. In the next section, we're going to finally write some Android related code and get our feet wet with Android development. Hello and welcome to section 2. In this section, we're going to look at the basic Android lifecycle and activities and how an Android app actually works. We're then going to look at how we handle resources in Android, so importing drawables and then referencing them. And then we're going to look at how we would go about producing an APK file and signing it, and then getting a Play Store listing ready for the future. In this video, we're going to go through the basic Android app lifecycle. So We're going to take a look at how an app starts and finishes and how it goes through its various activities, and then we're going to look at the manifest in further detail and then edit and add to it. When your Android app first starts, the first method that's ever called is the onCreate method. If you go into your main activity, you can see that the onCreate method is defined here. There's only one onCreate method in your app, and it is in the main activity, and that's what defines the main activity. It's then going to call the super onCreate method, and then that will then initialize your content view. Once your app has been created, your app has now started, and as a result has been set to a resumed state. These states are both the visible state to the user. Your resumed state is what your app consistently runs in, but this onPause method can be called in a variety of different ways. For example, when you get a call, your app will pause. If you press the home button, your app will pause. If you, for example, go into split screen mode, your app will pause, because in split screen, which was introduced in Android 7.0, only one of your apps can be active. The other one is in a paused idle state. OnStop is called when your app is either killed manually, or if your app has been in background for such a long time that it then gets stopped, and as a result gets destroyed. That's the basic gist of the Android lifecycle, and how this all works is through activities. You can think of an activity as like a screen. I believe I went through this briefly when we set up our Android app. And so this isn't just the lifecycle for your entire app, but this is the lifecycle for each activity. If I, for example, am in Facebook Messenger, I'm on this resumed activity. If I then go into a chat with my friend John, that activity that had the list of conversations will then go on pause, but my conversation with John will become resumed. And then, when I then back out of my conversation with John, that goes on paused, and the list of conversations then goes on resumed. The main activity also has to be further defined in the Android manifest, which you can find under manifests, Android manifest.xml. In here, we can see our activity.mainActivity. Underneath, we then have an intent filter. Now, each Android activity works on something called an intent. An intent is basically something that says, hey, let's go. That's probably the best and easiest way I can summarize that. So what this is then saying is, the intent filter for the main activity is that it's a main activity, and this is what's going to launch the app. The manifest is a file that is completely open for you to edit. When you add a new activity, you're going to have to be copy and pasting and adding new activities, essentially, just without this main attribute and this launcher category. Also in the manifest, you'll be adding something called permissions. I'm going to show you how to add an example permission for now. In your Android manifest XML, just outside of this application division, go ahead and type in users, and then the autocomplete will come up. Go on there, hit enter, and it will give you this huge list of permissions that you can then go ahead and access. So for now, I'm just going to add android.permission.internet, because that's one we're going to use eventually, and that's one I always forget to use. I always get some sort of HTTP exception, and I'm just like, why does this happen? And that is usually the reason why I forget, is because I forget to add that. And then go ahead and just close that tag, and hey presto, we have permission to access the internet in our app. In the next video, we're going to go through adding resources to our Android app and then referencing them programmatically. We're now going to add resources to our Android project. We're going to take a look at drawables in Android and how they're sized respectively, and how we're going to reference our resources in Android programmatically so that we can change our values on the fly. So, I've previously talked about the IC launcher.pngs, which is basically your app icon in the launcher. A good tip to remember here is that your Play Store icon and your app launcher icon are separate things. You can have a different icon for your Play Store listing and a different icon for when your app actually shows up in the Android launcher. But anyways, and there are 5 different versions of these. Again, MDPI, HDPI, XHDPI, XXHDPI, and XXX HDPI. Just to help you out, I've made a little table, and this table has the exact sizes of what your icon should be for each of these. And this should give you a rough idea of how different these sizes actually are. So now, say I wanted to import my own drawable. In an ideal world, I would make 5 different images, all with the ratios that I showed you previously. However, for now, I just have one simple image that I just want to show you just how to access through your Android code, just for example's sake. So I only have one image. So I've got this logo here, 256 by 256 PNG, and I'm literally just going to drag and drop it into, nope, it's not going to go in there. Copy, paste, there we go. Okay. Drag and drop didn't seem to want to work there. And now I have my logo in there. Now what I want to do is, in my activity main, all I want to do is, if I can find it, I just want to display this image. It doesn't really matter where this goes, I'll just drop it there. Give it a bit of time. And it'll ask me what I want to use. This was obviously a lot more difficult back in the Eclipse days, but nowadays Android Studio is very helpful, and it lets you pick a color from color palette, or it will let you pick a drawable, and I'm just going to use my logo there. Fantastic. Can I not shift it? Let's have it there. There we go. Marvelous. And that will scale depending on the type of display I'm using. And if you go ahead and click on this text view and scroll down to the image view tag, you can see that it's automatically referenced this @drawable, this folder, and then the logo 256. Job done there. The question you might now be asking is, well, how do I change these XML values in my code? Is there a way I can go about doing that? Yes, there is. As you can see, we can access these resources with r.layout.activity_main, we can access the resource of our activity main layout. So to access our text view programmatically and then change the text of it, we first have to initialize a text view object. Let's just call this TV. Then set it to a value, TV equals find view by ID. And the ID is r.id. There's our text view. And we can actually change this ID. If we go back into the XML, we can actually change this ID if we go back to the XML and just simply under Android:ID, just change this to TV. That'll give us an error here. Just change that to TV. And it's still giving us an error because we need to cast all of this to a text view. Because this method can return anything, really, you know, text view, image view, layout, anything. And then we can just simply do TV set text, and we can just access all the text methods from here. TV set text, instead of hello world, we're going to say hello universe, because we're just that great. You can then run this app in the emulator, or on your physical device. And there we have it. It initially launches with Hello World, but as soon as the app launches, it changes to our Hello Universe, and of course, it displays the image. In the next video, we're going to look at actually publishing and signing an APK, and then preparing a Play Store listing. We're finally going to learn how to publish our basic Android app. We're going to look at how we would go about creating the APK and then signing it, and then also readying a Play Store listing for upload. So in Android Studio, go ahead and click Build, Generate Signed APK, and we're going to create a brand new key store. So go into Create New, choose a path. I'm just going to create a new folder in the root of my hard drive and call it Android Stuff because I'm that organized. I'm going to create it there, and the file name is going to be Key Store because I'm creative. Give it a password. I'm going to call it Password because I'm just that secure. Give it an alias, so essentially just give it a name, EVH98. Again, password. Make sure that you do not lose this signing key file, otherwise you won't be able to ever publish your application again. And also be sure to use a strong password so that other people can't post applications under your package name. How long this key is going to be valid for? I believe 24, Oh no, I don't think there is a max. I'm just going to keep it at 25, just in case. I believe this is all optional, but go ahead. Yeah, I'll leave it there since it is all optional. Okay. There we go. Remember the passwords. I'm confident no one will hack into my computer. Next, set up a master password. Again, I'm just going to go with password. Or, yeah, I don't think there's any need for master password protection. I'm just going to leave it. For build type, if you are just exporting this APK just to simply install onto a friend's device or your own device, then go with debug. But if you're uploading to Play Store, then go ahead and click release, which is what we're going to do now. Finish. And then you can show in Explorer. And there it is. So in your web browser, go ahead and head on over to play.google.com/apps/publish, and that'll take you to the Google Play Developer Console. If that URL isn't valid, then just simply go ahead and do a Google search for the Google Play Developer Console. Pay the $25 developer fee if you haven't already, and then go ahead and add new application. And we're going to call this Best App Ever. Upload the APK. Upload first APK to production. And I'm just going to drag and drop this app release.apk into there. It's going to process it and check for any errors or anything like that. And then there you go. And we get an immediate summary of our supported devices, exclusive devices. We've made it pretty broad. And then you can go ahead and create your store listing here. Go through the content rating checks. Go through pricing distributions and all that. And once you're ready, you can publish your app. You can also see why you can't publish. And Google will give you all list of reasons. Hello and welcome to section Let's Get Rendering. In this section, we're going to take a look at the game loop, what it is, and how we're going to use it with our surface view. Then we're going to use the surface view to render shapes, and then we're going to have a look at events like touch and how our game is going to react to those events. In this video, we're finally going to use the Android SDK to start the actual game development of our game. We're going to take a look at the surface view and to set that as a basis for our renderer and how the system clock works and ticks. So first things first, we're going to want to make our game full screen without an action bar, without the status bar showing, without the navigation bar showing as well, like our normal Android app is. So how would we go about doing this is after the app is created, so after the onCreate method is called, but before we set the content view, we want to disable the action bar by request window feature, window.feature no title, semicolon, and then we can make the game full screen with get window.setFlags, window manager, go layout params dot flag full screen, comma, copy and paste this. Just gonna do it on a new line just so everything's all, in one place. Our content view isn't gonna be set to this XML layout. We're gonna create a brand new surface view, as I mentioned earlier, and use that to render our game. So here I'm gonna type in new game and pass in this activity. Of course, game doesn't exist. So we're going to go under app, Java, our package, and create a brand new class. And of course we're going to call this game. As I said, this game is going to be a surface view. Game extends surface view. And it also implements surface holder.callback. Okay. We're going to get an error here, so we can just click on that, hold Alt and hit Enter, and that'll give us a prompt to import that class. Okay, and of course we need a constructor, so public game, and we're going to give it a parameter of context, Alt Enter to import that, and we're just going to call the super method here, context. But we're still going to get errors here because there are unimplemented methods. And we're going to go ahead and override and implement those methods right now. So the first one is override public void surface created. surface holder. The second one is public void surface changed. Now this one's got a lot of parameters, so bear with me. Surface holder, an integer for format, another integer width, and another integer height. And last but not least, public void surface destroyed. And that just takes in a surface holder. So now we have all that. We need a thread for the game loop. It's probably best that we do this in another class. So new Java class, and we're going to name this game thread. So this is going to extend thread. Just the typical Java thread. And what a game loop actually is the concept of the game running through this loop once every frame. And you have a set amount of methods that run per frame. So in our case, we're going to have the game is going to call a render method and an update method, and they're going to be called once per frame. Our game is going to have 30 frames per second, so our game loop is going to be running at 30 ticks per second. So each time the game loop runs, I'm going to be referring to that as a tick. So this game loop is going to be creating this game thread. And then that's going to be called from the game, which is our actual surface, which is our rendering surface. And that's going to be within this main activity. Hopefully that's not too confusing. So in this thread, we're just going to define a few things. We're going to define frames per second cap, which in this case is going to be 30. We need to keep account of our average FPS, just so we can print that to the console, just to see what FPS we're getting. We're going to also need a surface holder. We need an instance of our game here. We need a boolean to keep track of whether or not the game is actually running. So if this gets destroyed, then obviously the game is no longer running. And we also need a canvas to actually draw on. And import that. So let's create the constructor, public game thread. This is going to take the surface holder and the game instances. I'm going to rename that as well. I don't want it to be that ambiguous. We're just going to call the super method and then set the surface holder that we pass in and the game instance that we also pass in to this thread. You should be familiar with the thread class in Java, and as we know, the thread has the run method, so we're going to override that run method, public void run. And in here we're going to initialize a lot more variables, and just bear with me, this is going to get a bit confusing. This is why a lot of people tend to go for other game engines that sort this stuff out for us, but it's good to know where everything comes from. And long target time. So just initialize these variables. And I'm going to go through them as we start using them, rather than go through what each thing is once we've initialized. So just initialize these variables as I've set them out. And let's go through the actual game loop. While the game is running, the start time is going to be equal to whatever the system time is in nanoseconds. We're going to initialize our canvas. And then we're going to try and lock the canvas. This.surfaceHolder.lock canvas. Synchronized surface holder. If that's a success, then this is the important part. From the game class, we're going to call the update method, which we haven't made yet, but we will go back and do that. In fact, we may as well do it now. So go back into game, and then let's just make public void update. So anything that you want to run with per tick that isn't a draw method, then that would go in update. So, for example, updating someone's health. That is something you'd want to update. but it isn't something you are rendering. So that's one thing we want called, and the second thing we want called is our game.draw, and that is essentially our render method. So these two, well, anything within this container is our game loop essentially. So because we're trying this, obviously we need to catch a potential exception. And finally, if the canvas is not null, we're going to unlock the canvas. But again, we need to try this. We need to catch this exception. So I realize that a lot of this is quite overwhelming and complicated. We haven't really got to the complicated stuff yet, but the block of code you need to focus on really here is this. This is the game loop. All this is just Android canvas stuff that is a bit tedious, but here is the game loop. Anything you want to update per tick, this is where you would. Now we can carry on with actually setting up this whole tick system. So time millis equals system.nanotime, which is the time after all this has happened. So we grab the start time, then we're going to grab the time again after all this has occurred, and we're going to subtract it from our start time. And we're going to divide this by 1 million, and this is then going to get the time after all this in milliseconds. Remember, we grabbed the time in nanoseconds. We're then going to divide it by a million to then get it in milliseconds. We're then going to specify a wait time. So how long are we going to wait until we should draw again? Because there's no point drawing unnecessary frames out there. So we're going to grab our target time, which is 1000 over our FPS. We're going to grab our target time and subtract that by this time that we've just taken here. We're then going to execute this wait. So this dot sleep for the time we need to wait, and then catch this exception here. And then this isn't necessary for the game loop, but this I just want to show you, and that's to calculate the average FPS. So how we would do this, we would grab the total time and add the system time at this point minus the start time, increase the frame count by 1, and then as soon as the frame count then reaches that FPS, we're then going to calculate the average FPS, which is 100 divided by the total time divided by the frame count, and all of that divided by, once again, 1 million, so that we can have it in milliseconds. Then we're going to reset the frame counter, reset the total time, and finally print out our average FPS. Before we go back into that game class, we want to make one final method, and that's public void set running, just so that we can change the value of this running boolean outside of the game thread. So set running to boolean, just so we can start the game and kill the game. Running equal is running. Hop back into our game class, and we're gonna now initialize that thread. So private game thread, and then give it a value. Before we do that, we're going to get holder add callback. This is just so that the callback is set to the surface view, so that we can have events triggered from here. And after that, we're going to make our thread equal to new game thread, get holder, and then pass this game in. We're then going to make this surface view the focused view. And as soon as the surface is created, we're going to thread.setRunning to true, and then we're going to start the thread. Once surface is destroyed, we're going to first create a boolean called retry, because it can take a few times to actually attempt to kill the thread when the surface is destroyed. So while retry is true, go ahead and set the thread to false. Thread.join, catch that exception as an interrupted exception and print. And once that's accomplished, then we don't need to retry it. So, to recap, if we go into the main activity, the app gets created, everything is then set to full screen, and the content view is set to this game, which has provided the context of the main activity. The game starts, everything is initialized, including this thread. Once everything's initialized, then that surface has been created. And as soon as the surface has been created, the thread then gets ran. The thread starts to run, and because running is set to true, this game loop is going to kick off, and there this game.update and this game.draw canvas is going to update 30 times every second. So if we go ahead and run this, and as you can see, our game is outputting at 29 FPS consistently. Good enough. Just a slight amendment before we run the game. This is meant to be 1000, not 100. In the next video, we're going to look at how to actually render shapes and colors. In this video, we're going to look at how we're going to render in our surface view. We'll look at how we're going to declare shapes and then color those shapes using the paint class. So before we actually dive into the rendering, I want to focus on this block of code just for a second. Now, this is the block of code that enables our game to go full screen. However, this is how it was done pre-Android 4.4, so before KitKat. Since then, Google have recommended this is the best way to go full screen, or as they like to call it, immersive mode. So again, it's just get window, and instead this time it's, instead of set flags, it's get decor view, so get decoration view, set system UI visibility, and there's a lot of these, so I'm going to do each one on a new line. First one is view.system UI flag layout stable, there. Next one, not a comma, it's a pipe. And then we will actually, I'm going to have this on a new line. That's what it seems to be hinting at what it wants. View.system UI flag layout hide navigation. View.system UI flag layout full screen. View.system UI flag hide navigation. View.system UI flag full screen. And finally, view.system UI flag immersive. And there we go, we finally have that sorted. Now we're going to render a player. So what I'm going to do is, in the Java folder and right here, I'm going to create a new class, new Java class, and I'm going to call this player. Now, the player is going to have a rectangle as its bounds, so that's the shape it has. Just Alt-Enter to import that. And it's also going to have a paint. So we want to be able to actually paint this rectangle. We're going to have an initializer, player rect, but instead of a paint, we're just going to pass through a color, and colors are stored as integers in Android, or rather in the Android SDK. And so as a result, we're then going to set this rect equal to the rect that's passed in, and we're going to set paint equal to a new paint, so initialize that paint, and then set the color of that paint to the color that we pass in. So that's our player initialized. So go ahead and create a draw method for this player, and in here we're going to canvas.drawRect with our rectangle and our paint. Hop into your game class, and here we're going to initialize an instance of our player. I'm going to do this above set focusable, so player equals new player, and this takes in a rectangle, so new rect. And how this works is we're going to put in our starting coordinates. So I'm going to start, doesn't really matter, 256, 256, and I want to end it at 384, 384, giving me a 128 by 128 rectangle. And we're just going to pass it through a color of blue. Scrolling down, you'll notice we don't actually have a draw method. So at override public void draw. Oh, that needs a canvas. And we're just going to call player.draw and pass through that canvas. And we should be good to go to test the app. And there you see we have our little blue player on our screen. In the next video, we're going to look at how we're going to register events in our Android game. In this video, we're going to have a look at registering motion events in our Android game. So we're first going to register whether or not a user has actually touched the screen, and if they do touch and move around on the screen, we're going to transform our shape. So in our player class, we're going to want to add an update method now, along with our draw method. And instead of having no parameters, we're going to pass through a parameter called point. This is because rectangles are weird and how they're drawn, as we learned earlier. Basically how it is you give an X and Y for the top left corner, and then you give an X and Y for the bottom right corner. That's ideally not how we'd like to do it. We'd rather just pass in an X and Y from the top corner and just go, rather than giving two sets of X and Ys. So this update method we're going to make, that's going to essentially grab the values that we're going to give from a point, and a point is just an X and a Y value. That's going to grab the values from there and then adjust it to this weird rect format. So, it sounds a bit complicated, but it needs to be done. So rect set, and firstly we're going to grab the X of the point and subtract it from half of the width, and then we're going to get the Y and subtract it from the half the height, and that gets us our top left sorted. Now we need to sort out our bottom right, so you can copy and paste all of that and simply exchange these pluses, exchange these minuses for pluses. Now we actually need a point, so if we go back into the game class, right underneath the player, go ahead and create a player point. Initialize that right underneath the player, equals new point. Now, instead of this, we can just simply put 0, 0, 1 to 8. This is essentially saying start from the very start of the screen, the top left of the screen, and end at 1 to 8, 1 to 8. Essentially saying I want this to be 128 by 128 in terms of size. Then, in this point, we can then say where on the screen we want it, rather than doing both in this rect, because defining a position and a size all in one is a bit confusing and a bit annoying, really. So, here, I'm going to, I don't know, I'm going to give it an X of 256 and a Y of 960, because why not? Okay, we need to call this update method, of course. So, player.update with that player point. And finally, all we need to do is just register the touch event. So go ahead and add this method, override public boolean on touch event, and we're going to pass in a parameter of motion event, and this is always going to return true, because we always want to be checking for a touch event. And in here, we're going to add an if block, event.getAction, so get that touch event that may or may not have happened, and we want to see if it's a certain type of motion event. And you see, if we go into this motion event class, there's a lot of them. There's a plethora of motion events to choose from. We just simply want move. So if the user has put their finger down the screen and is moving around, if that's the case, we want this player point set to, and as you can see, we're now using X and Y. So the X position of the event and the Y position of the event. However, I don't want the Y position to move. I only want the player to be able to move left and right. So I'm going to keep that constantly at 960. I'm going to paste that in. And again, we still have an error because this is a float, but the method wants an integer, so we're just going to simply cast it. Now, I'm going to run the app now, however, it is going to have one glaring issue, and I do want you guys to see this before we actually fix it. Now, if you have a look, again, we have our blue rectangle just in a different spot. If I start to move it, it doesn't look like it's moving, it all looks like I'm stretching it out. That's not what's happening. It is moving, however, it's just drawing over the previous image over and over again. All this black isn't actually black, it's all transparent. So this is just simply rendering on top of one another. We're not actually clearing the background and regenerating it over and over. And that's something we should do. So it's just a simple one line of code right above this play.draw, and before anything else is ever drawn, we want to set the color of the canvas to... we want to draw a color onto the canvas. And we can go with the black, or we can choose whatever we like. So I'm going to go with white now, just for a bit of change. And if I then run the app again, you can see first of all we have our nice white background, but also if I'm moving this around, it moves as you would expect it to. Welcome to section Enhancing the Game. In this section we're going to take a look at the scene system and how we go about creating our own, using animations in Android, and then using the accelerometer in our game. In this video we're going to go over scenes in our Android game. We'll be looking at creating an abstract scene management system and then creating different scenes for the main menu and the game. We're first going to create a scene interface, so go ahead and create a new Java class, but it's going to be of type interface because all we want to do is just create a set of methods that the scene is going to implement. And so these methods are going to be public void draw, and public void update, just as we've been doing so far, and also a public void terminate, a method that will run when we close our scene and move on to a new one. We also want our public void receive touch, and that's going to take in a motion event. From this we can then create a brand new scene. So we're going to create our gameplay scene. Okay, and it's going to implement that scene interface that we made. Now the reason we are splitting up our game into scenes is so that our code's not all in one class. So I can have the main menu as a separate screen, I can have this gameplay as a separate screen, I can have the help menu as a separate screen, and so forth. And it also reduces redundancies. Things like if I go into the game class here, so things like all this block of code and all this block of code, things like that, they now become redundant. Things like that don't have to be written twice over. They can all be written here, and we can just focus on the actual game logic and rendering in our scenes here. So just carry on overriding these implemented methods. Once we've done that, we can actually copy and paste this gameplay scene and rename it main menu scene. And now we have the template for our main menu scene here. We now need to create a scene manager, something that's going to handle all these scenes together. And we're just going to create a new class called scene manager. And the scene manager is going to have an array list, which will essentially be a list of all our active scenes. And it's also going to have an integer, which is going to act as the active scene. So this integer will keep track of what actually is our active scene that we are going to display to the screen and update. And then we can create a constructor, scene manager, and once the scene manager is initialized, we just want to make sure that the active scene is the first scene. So set active scene to 0. We then can add our scene, so scenes.add, and we can add our main menu scene, which becomes scene 0 because it was added first, and then we can add our gameplay scene. Now we need to add our overhead methods because we want this scene manager to render the current scene. Scenes.get active scene.draw. To grab whatever the active scene is and run its draw method. And we need to do the same for the update method. Again, same thing here really, we can just copy and paste and just change this to update. And we can do the same for receive touch. Now we have our scene manager set up. Now what we can actually start to do is, from our game class, we can start moving over things that should now be in our gameplay scene. So in our gameplay scene, we should actually create a constructor, public gameplay scene. And we're going to cut and paste this section because these things need to be relevant for all scenes. However, these lines of code are only relevant to the gameplay scene. Import all the following. It's going to give us an error because we don't actually have that player and player point, so we can cut and paste that. What else? This motion event. We can grab this method that is relevant to our receive touch because that's only relevant to the gameplay scene, and we can keep this return true here. The player draw is only relevant for the gameplay scene, and of course the player update as well. Now I'm just going to copy and paste this into our main menu scene. I'm just going to have it, if we touch the main menu scene, then just change it to this gameplay scene. How we're going to go about that is, when the main menu scene is just touched, we're going to run this terminate method. And terminate, what that's going to do is it's going to go into scene manager, and it's going to get the active scene and set it to 1. Because our main menu scene is 0 and our gameplay scene is 1, and we want to now set it to the gameplay scene. Now in our game, we need to actually add this scene manager in there. Because at this moment in time, scene manager is just sitting there and not actually doing anything. Manager equals new scene manager. We now need to reference all these scene manager methods in the actual rendering panel. So we're going to go down here, and here we're going to call manager.receiveTouch and pass in that motion event. In the draw, after we've reset the canvas to white, we then want to manager.draw. And in the update method, we just want a manager.update. And the manager itself will then handle what the active scene is and then run the method for that relevant scene. Now as you can see here, we have our blank main menu screen. If I then touch here, there we go, we are now presented with our game screen. In the next video, we're going to be looking at animating our player. In this video, we're going to look at using bitmaps and animating them to animate our player. We'll look at how we are going to render these bitmaps in Android and then create an animation engine to stitch them all together. First things first, we want to create a static instance of our current context, and this is so that we can access the resources that we're going to be using for our animation. So go ahead in the game class, write public static context current context, and then we're going to make this current context equal to the context that we pass in up here. We're now going to go ahead and create an animation class. The animation class is going to contain an array of bitmaps, and that is essentially going to be the frames. Import that. We're going to keep a tab on the index of the frame that we're on, so our current frame. We're going to keep count of how long each frame is going to last for. We're going to keep account of the last frame and whether or not this animation is playing. In our constructor, we're going to pass in these frames, and how long the animation is going to run for in total. I'm going to set this frames equal to the frames that we pass in. The frame index is obviously going to start at 0. The frame time is going to be the overall time divided by the amount of frames that we actually have. And the time of the last frame is going to be the current time in milliseconds. For our animations draw method, we're going to pass through a canvas, of course. We're also going to pass through a rect, and this is going to be the destination of where our animation is going to be rendered. Because how a bitmap works when it's being rendered is, okay, it asks for an image, and it takes that image, but then it wants to know where exactly it wants to draw it, and as a result we pass through a rectangle to show it where. So first we're going to check if the animation is playing. If it isn't playing, then we're just going to return nothing. If the animation is playing, then on the canvas we're going to draw a bitmap. That's going to be frames, frame index, whatever the current frame is. Next parameter is null. Then we're going to pass in through our destination and then a paint. We're then going to write an update method, in which again we're going to make the same check. If the animation is not playing, then just return. If the animation is playing, then we are going to check if the current time in milliseconds minus the last frame is more than whatever the frame time should be in milliseconds. We're going to pass it in as seconds. So basically it's going to check whether or not the current frame has finished. If that is the case, then we are going to go forward to the next frame, and we're going to increment the frame index to do that. We're then going to check if the frame index has surpassed the frame's length, so has the animation cycle completed. If so, we're going to reset the frame index back to 0. And then we're going to set the last frame once again equal to the current time in milliseconds. We then need play and stop methods, so public void play. Frame index is going to start off at 0 when we play it, and again we're going to set the last frame equal to the current time, and simply is playing is going to be true. And then for the stop method, we're just going to simply set playing to false, because everything else gets reset in the play method. And then, because isPlaying is a private attribute, we're going to create a public boolean isPlaying method so that we can access the value outside of this class. Now, just like we did with the scene manager, we're now going to create an animation manager. The animation manager is going to create an array of these animations, and also an animation index, which is going to be the current animation. In the constructor, we're going to pass through all of our animations, set the animations to the animations we pass in, and then set the animation index to 0. Then need a method to play the animation, and we need to specify which animation we're going to play. We're going to loop through all of our animations and if we find the correct animation, and if it's not already playing, then we're going to want to play the following animation. Otherwise, we want to stop the animation. Because we don't want two animations running at once. And then after all that is said and done, we can set the animation index to whatever the index we pass through in. And a rect And then we're going to check if the animation is actually playing. If so, then we can go ahead and draw the animation. We can pretty much copy and paste this for the update method and just rename this to update, clear these parameters, clear these, and change that to update. We're finally done with all our background animation stuff, and we can now go ahead and implement this animation into our player. So go ahead and create two animations. So we've got private animation idle, and we're going to have another one called walk, and it's going to have an animation manager. In the constructor, go ahead and create a bitmap factory, which is essentially going to create our bitmaps. And we're going to take in our bitmap image idle that we have here. And we're going to take our current instance that we made in our game class and then get the resources. It's going to be located r.drawable.whatever the file name is, so idle. And then this process is repeated for the other images. We can now go ahead and create our idle animation. And because it's not really an animation, we're just going to pass in a singular image, which is our image idle. And once again, it's not really an animation, so it doesn't matter what time we set it, so I'm just going to set it to 1. We then need our walk animation, and this is going to take in two images. It's going to take walk 1 and walk 2. And I guess half a second would be okay for the total animation, 0.25 seconds each for each of them. And then we need our animation manager to actually take in these animations. So a new animation array, and it's going to contain idle and walk. In our draw method, because we're no longer actually drawing this rectangle, but instead we're drawing our bitmaps, we can do animation manager.draw, canvas, and rect. Now here, first we need to implement some code that will make sure that our player knows whether or not we're actually walking or idle. So we can measure the initial position by just taking the left of the rectangle. Further down we can set a state as 0, and 0 would be our idle state, and it would also have our index animation of 0, and as you can see 0 would be our idle, and then 1 would be our walk. So 0 if that position hasn't changed. If it has by a considerable amount, so if rect.left minus initial position, so if the change in position is more than 5, so that's for the right, and this is for the left. If that position is changed, then change the state to 1. And then in our animation manager, we can play the animation depending on whatever state it is. And then we can also update our animation. Go ahead and play this. As you can see, my player now is idle, but if I move it around quick enough, then it is then animating. And the reason for this stutter is actually because of the screen recording. In the next video, we'll look at how to use the accelerometer with our Android game. In this video, we're going to take a look at sensors. More specifically, we're going to look at how we can use the accelerometer to control our player's movement. So first of all, we actually need to prevent our game from auto-rotating. So in the Android manifest XML, go ahead here where it says activity Android name main activity, just before this symbol here, go ahead and press enter, and then you want to type Android : screen orientation portrait, and this will lock our game to portrait. Once we've done that, we can then create a new class. We can call this sensor data, and this is where we're going to track the accelerometer in our game. The sensor data class is going to implement the Android interface sensor event listener, and in this class we're going to create an instance of a sensor manager. We're also going to create a sensor and a float array to track our accelerometer values, since the accelerometer will give one float for the x, one float for the y, and one float for the z. So that's 3 floats which will go into this array. The constructor is going to set the manager equal to game.currentContext .getSystemService context.sensorService. Essentially, get the sensor manager, and we need to cast this to sensor manager. The sensor is then going to equal the manager.getDefaultSensor, and the sensor type is going to be the accelerometer. So this essentially tells the sensor manager, we want to grab the accelerometer from your long list of sensors. And then the manager is then going to register a listener, and that's going to be this class and the sensor. And then we want to tell it how much delay we're going to, or how frequently I should say, the sensor should update. So we want sensor delay game, because if we were going to have sensor delay normal or sensor delay UI, it wouldn't update that frequently, whereas in a game we need it to be updating quite constantly. This interface implements the methods public void on accuracy changed, which we actually won't be using, but we have to add it anyways. And the one we'll actually be using is public void on sensor changed. And that's going to take in a sensor event. We're just going to make the accelerometer, so this float array here, we're going to make that equal to whatever the values of that event are. And we also want to be able to grab this private float, so we're then going to create a public get accelerometer method, and that's just going to simply return that array. We can then open up our gameplay scene, in which we can create an instance of this sensor data class, and simply set sensor data equal to new sensor data. And in our update method, just before this player.update, what we're going to do is, when the phone tilts left and right, we're just going to update our player's X position with that. But also have touch as an option as well. So just before this player.update, we're going to add if the accelerometer isn't null, then go ahead and player.point.set. Again, we're going to have the Y the same, but the X is going to be cast to an int, because we're going to get a float from this. Sensor data dot get accelerometer, and remember it's an array and we need X. X is at index 0, Y is at index 1, and Z is at index 2. Now since this requires a physical device to test, I can't actually show you this running. Welcome to section the Libgdx library with OpenGL. In this section, we're going to take a look at setting up our basic Libgdx game, looking at how the lifecycle of a Libgdx game worked, and then going through the screen system, rendering using the orthographic camera, the sprite batch, and the shape renderer, using a sprite sheet to loop through an animation, and then looking at audio through sound effects and music. We're now going to take a look at creating a basic Libgdx app. To accomplish this, we're going to look at downloading and running the setup app, and then importing the resulting Gradle project into Android Studio. In your web browser, go ahead and visit libgdx.com, hit the download button, and then download the setup app. Once that's finished downloading, go ahead and click on it. And then here we're going to set up our Libgdx project. I'm going to call this example game, just very simple. And the package is going to be com.vh98.example game, and the game class is just going to be example. That's going to be the main class. We then want to browse the path of our Android SDK, and it's just simply the entire SDK folder. Go ahead and open that, and then select a destination for the project. Make sure the directory you've selected is completely empty. We only want the Android project, so we're just going to go ahead and deselect all of those. As for extensions, we're going to need FreeType and controllers. Under Advanced, go ahead and click on this Idea button and then Save. And Generate. In Android Studio, go ahead and click on File, Open, and then open your project. Once you've found the folder for your project, go ahead and click on this example.ipr and then hit OK. We now have our core project and our Android project. Our core project is simply where we'll be writing all of our main code. And then the Android project is where we will store our assets and also where we will launch our Android version of our game, since Libgdx is cross-platform. In the next video, we're going to be looking at the Libgdx screen system and app lifecycle. In this video, we're going to look at the Libgdx screen system. To begin with, we'll take a look at the lifecycle of a Libgdx app, and then go through the basic screen layout and the methods we're going to have to override. So Libgdx lifecycle is actually pretty self-explanatory from this image. However, I'm going to go through it anyways, especially since this doesn't actually cover the whole screen system, although it's not that much different. So once the application starts, we're going to run our create method. In our create method, we're going to initialize all of our screens and then set an initial screen. This resize method is then run, however, all of our resizing is going to be done through the orthographic camera, which is going to be in the render method. So we don't actually need to worry about this, we're just going to skip that completely. And then whilst the application is running, this render method is continuously running. And note there isn't actually an update method. In Libgdx, all of your rendering update should be in the render method, however we're going to make our own update method anyways, just for organization purposes. And then also, this pause is also always listened for, so whenever the app loses focus, this pause runs, just so, your game's still not running in the background, so your player ends up dying when all you've done is press the home button. And then once focus is regained, it goes back to resume and the application continues running. When the application closes, this pause runs again, and then all assets are disposed out of memory. So in Android Studio, the first thing you're going to want to do is actually delete this example, because we want to start fresh. They actually give you a template example main class, but that assumes that you are not using the screen system. So we're going to extend game and then import that. And the only thing that should be in our main class is this public void create. And that is where we'll initialize our screens and then set the main screen. So let's go ahead and create a screen. So new class, and we're going to create a main menu screen. Obviously this is going to implement screen, import that. And it also needs a constructor, so public main menu screen, and it's going to take in an instance of our game. Now this is because when we want to run methods such as exit game or change screen, it wouldn't make sense for the screen to actually execute any of these tasks, considering it's the actual game itself at concern. If I want to exit the game, then I would have to speak to the game about it first. If I want to change screen, I would have to speak to the game about it first. The game is essentially where the master controls are held. So in our main menu screen, we're going to create a local example and then set this example equal to example. And there's a lot of methods that need to be implemented here. So the first one is public void show. And the show method is essentially the create method before a screen. Now the difference between actually doing something in the constructor and doing something in this show method, anything ran in the constructor is ran as soon as the game is created. Because what we're actually going to do is, we're going to do main menu screen equals new main menu screen, which takes in this. So as you can see, anything that is in the constructor is just going to be ran as soon as this game is created. However, with the show method, as soon as that screen is displayed for the first time, that's when the show method will run. The next method is the self-explanatory render. However, it does take an argument of delta, which we won't be using for a while, so you don't have to worry about that anyways. The next is that pesky resize method. However, since we don't need it or plan to ever use it, we can just do it all on one line, just so it's out the way. The next methods are, again, the self-explanatory pause and resume. We then also have a hide method, which is essentially the opposite of show. Once the screen changes, then the hide method is ran. And then finally we have this dispose method, which is executed when the game is exited for all screens. Hop back into our main class and we can actually go ahead and set the main menu screen as our initial screen. In the next video, we're going to actually start rendering things in our Libgdx game. We're finally going to render things in our Libgdx game. We're going to look at the orthographic camera and how it works, and then initializing OpenGL for our Libgdx game, then using the sprite batch to import sprites, then we'll import sprites and then use the sprite batch to render them, and then look at rendering shapes as well using the shape renderer. So the first thing in our main menu screen that we need to create is an orthographic camera instance. And essentially, well, you could probably guess the orthographic camera is the camera for our game. So we're simply going to initialize this as a new orthographic camera. And then we're going to do camera.setToOrtho. This is essentially initializing all the camera attributes. And the first one is Y going to be down or not. Libgdx's default viewport is that instead of Y being drawn from top down, Y is actually bottom up, as it would be in a mathematical graph. So in this case, we're going to put down true, just so Y is in the downwards direction like it normally would be. And the width and the height generally is the maximum resolution that we're going to support. So what the orthographic camera will then do is, it will render at this max resolution and then scale down accordingly. So it's better to target a maximum resolution and scale down, rather than target a lower resolution and then scale up. So nowadays phones are maxing out at about 2K, which is a 1440 horizontal resolution and a 2560 vertical resolution. We also need to initialize a sprite batch to be able to actually draw our sprites. That's just a simple initialization. Now we can scroll down to our render method and start initializing OpenGL. So we're going to write gdx.gl.gl clear color. Actually, importing that gdx would help. GL clear color. And this is essentially the set background fill that we had earlier. And we now get to set a background color with using RGB values. And so I'm just simply going to have it as 1F, 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 and an alpha of 1F. And that's just going to clear it to white. And then we need to clear the screen in general using GL20. GL color buffer bit. You don't really have to be concerned with what that actually means. Then we have to call a camera.update method so that it can update its matrices. And then batch, sprite batch, dot set projection matrix is going to be camera.combine. So it's essentially going to then take this orthographic camera, whatever resolution it is, and then convert all the coordinates and stuff down to whatever we're actually rendering to using our sprite batch. And then simply sprite batch.begin and sprite batch.end. And here is where we are going to be writing all of our rendering code for our sprites. So as you can see here, I have this play image, which is 1440 in width and 2560 in height. And I'm just going to simply render this on the main menu, and then we can click anywhere to play, and that will take us to the game screen, which we'll make as well. So I'm just going to copy this, and then paste it in the Android assets folder. Okay, and it can be a PNG or a JPEG, doesn't matter. And I'm just going to delete this old badlogic.jpg example file. And now we can render this play image. Now we need to add this to our Libgdx game. So we're going to create a sprite. And this sprite is going to be our play PNG. And we're simply going to initialize this as play equals new sprite. And sprite is going to take in a libgdx file handle. So we're going to write gdx.files.internal. And internal is just this assets folder here. So all we have to write is play.png. and then we need to flip this play, and not in the X direction but in the Y direction. The reason is because, like I said, Libgdx's default is Y down to up, but we've changed that. We've gone with the normal Y down method rather than Y up. So we need to flip the sprite. It's going to give us an error because this actually needs to take in a texture, so we're just going to do that. And then simply we can just write play.draw, and it's going to take in this sprite batch. And as you can see, it has worked. However, there's two little hiccups. One, the navigation bar is still present, and two, it's in landscape and not portrait. So we need to fix that. So just simply double click on the Android manifest and go under Android screen orientation and just change that to portrait. And then under Android and Java, go into the Android launcher, and then just after this line, write config.immersive, and you'll find this use immersive mode, and just set that equal to true. We can run this again, and now it's running how it should. Now I'm going to show you how to use the shape renderer, and to do this, we're going to copy and paste this main menu screen and create our gameplay screen. We're not going to need any sprites in this, so we can get rid of these, but we are still going to be using the camera. Now instead of the sprite batch, we can use the shape renderer to create our player. And again, initialization is the exact same. We can just simply write shape renderer equals new shape renderer. And we don't need to initialize a sprite or anything like we did for the main menu PNG. We can just go as it is because this is just a shape. Once again, like with the sprite batch, we do need to set the projection matrix of the shape renderer to the camera.combined. And then shapeRender also has a begin method and an end method. However, this begin needs to take a shape type, and this shape type is either filled, line, or point. Most commonly, you're going to be using filled, so we're just going to draw a simple rectangle for our player. So all we have to do is write shapeRenderer dot rect. And this is going to take in an X position, a Y position, and a width and a height. I'm just going to simply render it to the center of the screen, which is going to end up being half of the width subtracted by half of the width of the actual player itself. However, I'm going to actually create these variables separately in X and in Y, because we're going to be changing these values over time, because what the player is actually going to do is it's going to change its position once every few seconds. So in X initially is going to be half of 1440 minus, we'll give it a width of 128, so minus 64. And in Y is initially going to be equal to 2560 minus 2, divided by 2, minus, once again, 64. So we can just X, Y, 128, 128. We should set color, so shapeRenderer.set color. Color dot, let's go with blue. Let's go with blue. And now if we go back into our example and initialize this gameplay screen, and then set the gameplay screen as the initial screen, you can now see we do have our little player. Now, like I said in the first video of this section, we're going to be creating our own update method, just so not everything is all cramped in this one method. And in this update method, we're going to initialize a timer. So now, like I said, we need to change these X and Y values every couple of seconds. So we're going to initialize a timer and schedule a new task. And import that. And remember to add a semicolon. And in this new task, we're going to have an overridden method called run. And this is the method that we're going to essentially be running every X amount of seconds. And the first parameter after this method is the delay. We're not going to have any delay, we're just going to have this method run as soon as possible. And how many seconds? So I think I'm going to have this change position every 2 seconds. That should be okay. Okay, now I finally got that sorted. And so what we're going to do is we're going to generate a random number between 1 and 1440 for X and 1 and 2560 for Y. So first initialize a random object and import it from Java util. And X is going to be equal to r.nextInt 1440 and Y is going to be equal to r.nextInt 2560. And before we run it, it's actually probably best that we move this timer schedule into the show method rather than the update method, because it's already scheduling an event that should run every 2 seconds, so it shouldn't be consistently ran in this method. As you can see, every couple seconds our blue square is moving around the screen. In the next video, we're going to be looking at using a sprite sheet for animation in our Libgdx game. We're now going to go through animation in our Libgdx game. We're going to take a look at importing and using a sprite sheet, and then looping these sprites in an animation. Instead of this play image, what I've now done is created a sprite sheet of various different play images, and we're just going to animate through all of these different colours just to give our game a little bit of flavour. And as you can see, I've also cut out this unnecessary white space, and so instead of having this as a 2560 1440 image, this little box here is actually half of 2560, which is 1280. So each of these boxes is 1440 by 1280. And here, as you can see, I have 3 across and 2 down. So I have 3 times 1440 and 2 times 1280, which brings us back to 2560 vertically. I'm just going to copy and paste this into my Android assets folder. And now, instead of a single sprite, what we're going to do is we're going to have a texture play sheet. And this play sheet is just going to be equal to a new texture. We can just get rid of that and rename this to play sheet. And same here. The texture doesn't actually have a flip method, so we can remove that and we'll flip it all later. Now what we also need to create is a texture region array. And a texture region is essentially a region of a texture. And we're going to need an array because we have 6 of these. And this is going to be called play frames. We're going to have a temporary texture region, temp. And this temporary texture region is going to be equal to texture region.split. And we're going to take in our play sheet. And the tile width is basically the width of each tile. And so that is 1440 and the height is 1280. Just essentially the size of one tile. And then as a result, our play frames are going to be equal to new texture region array, and it's going to have 6 items in it. And now we need to loop through all of these. So what we're going to do is we're going to create an integer of index 0, and then create 2 different for loops. So in this one, we're going to loop through the rows. So when I is less than the amount of frame rows, there's 3 rows, and increment I each time. And then another one for the vertical axes, and there's only 2 columns. Sorry, there's 2 rows and 3 columns. I'm getting myself mixed up here. And what we're going to do is, for each temporary texture region that we grab, we're first going to flip it, not in the X direction, but in the Y direction, and then we're then going to set each index of the play frame equal to whatever temporary frame we've just grabbed. So essentially what this is doing is, we're grabbing these texture regions as a multi-dimensional array, and we're just essentially converting this multi-dimensional array all into one singular array. That is essentially what all of this is doing. Now we need our actual animation, and we're just going to call this play animation. Import G2D, not G3D. And then down here we can set play animation. And this is going to be a new animation which is going to take in the speed of each frame. So I guess every half a second. And then it's going to take in our frames. Final variable we need is a float state time, so the time it takes for each state to run. And I lied, that's actually not the last variable. We also need a current frame to render. So the initial value of this state time is simply going to be 0f. And then down in our render method, just before we start actually rendering anything, we're going to set this state time plus or equal to the delta, just so our animation is in time with how many frames per second we're actually rendering. And then after we've done that, we can set the current frame equal to our play animation dot get keyframe state time, and true, we do want this animation to loop. Then in our sprite batch we simply write sprite batch dot draw current frame, and we can set the X and Y. And because this isn't a full 1440 by 2560 image, we are going to have to position this slightly down, so 640 and 0, that will give us our expected position. My apologies, I actually seem to have gotten my X's and Y's mixed up there, so 0, 640. And then remember, before we run this, in our example main class, go ahead and swap this gameplay screen to the main menu screen. And then we can go ahead and run our game. And there we have our beautiful animation on our main menu screen. In the next video, we're going to be looking at using audio in our game. We're now going to take a look at audio in our Libgdx game. We're going to take a look at using sound effects and also music, and then finally we're going to go through disposing all of our assets. Now I have this sound file called sfx, and this sound file is essentially just going to play every time that the player moves. So I'm going to copy and paste this into my assets folder. And then in my gameplay screen class, I'm going to initialize a new sound, and this is just going to be called effect. Effect is going to be equal to gdx.audio.newSound, and it's going to take a file handle, so we'll give an internal file handle, and it's just called sfx.wav. Literally very similar to a texture, and all we have to do is in our timer schedule, just simply add this effect.play. And remember to swap the screen to the gameplay screen before you run and test this. And now as you can see, each time our player moves, the sound effect is triggered. You can add all sorts of properties to these sound effects. So you can have effect dot, you can set the loop, you can also set the volume and the pitch and everything. And if you have anything that's maybe longer than what would be considered a sound effect, something that's like, 15-20 seconds long, which would be considered as music, you can simply swap this out for music as opposed to sound. And finally, we should be disposing all these objects that we're using. So go ahead and go down to this dispose method, and we're going to dispose. We can't dispose the camera, so we're going to dispose the shape renderer and dispose our sound effect. And again, in the main menu screen, we're going to dispose. Oh god, okay, let's see. Let's just take this one step at a time. Let's dispose the sprite batch, dispose the play sheet, and that should be all. Welcome to section User Interaction. In this section we're going to take a look at registering touch events, registering our own custom fonts and then rendering them, saving data using shared preferences, and interacting with the physical world using the vibration and accelerometer functions of Android in our Libgdx game. we're going to register touch events with our Libgdx game. In this video, we're going to look at registering touch input, whether or not a touch has been registered, and querying the position of a touch. So in our main menu screen, we're going to create a local update method. Like we did with the gameplay screen, all of our update is separate from this render class. So public void update. And here we're just going to have a simple if statement. If gdx input.is touched, and if anywhere on the screen is touched, then we're going to go to the gameplay screen. How we're going to do this, if you see, we initialized our screen with an instance of this example class. So what we can then do is, we can write example.setScreen, example.gameplayScreen. Now we can hop into our gameplay screen, and what we're going to do is, we're going to detect whether or not the player's finger touches wherever the blue rectangle is. And each time the player does that, the score is going to get incremented by 1 each time. Now because we need exact coordinates and not whether or just, a touch anywhere is detected, we're going to need a slightly more sophisticated method. So we're going to create our own public boolean, so it's going to return true or false, is touched. This is going to be our local is touched method. And the parameters are going to be x, y, width, height, a vector3 touch, and that should be all. So what we're going to do is, we're essentially going to be asking, right, wherever the user has touched, does it enter this sort of rectangular area that we're going to have? And that rectangular area is going to be our rectangle here. So in this method, actually before we delve into this, we should probably create a vector3. Just create this here, vector3 touch, and this is going to essentially parse our touch as a 3-dimensional vector. So here we're going to touch equals new vector3. Then we can go back down to our isTouch method. In here we're going to have again our if statement of if gdx input is touched in general. If that is the case, then we're going to grab our touch vector3. Actually, we don't need to even pass this through because we have this up here. If it is touched, then we're going to set our touch to whatever the x coordinate of our touch was, and same with our y coordinate. And we're not in 3D, so we don't need a third value. If that is the case, then camera unproject touch. So because the orthographic camera works for different resolutions, so it needs to detect, it needs to actually convert all of this. And then if touch.x is less than or equal to the x that we pass in, and touch.x is less than, is more than or equal to this x, and touch is less than or equal to x plus width. So again, we're just testing whether or not this touch is within a set rectangular area that we're making. And, not a comma, and if touch.y, and again, same logic with y, if touch.y is more than or equal to y, and touch.y is less than or equal to y plus height. And that should be it. This set should not have had a curly bracket. That's just, there we go. That tidies it up a little bit. Yeah. Now, if that's the case, then return true. If none of this is the case, then return false. And there we have our touch is touch method. We can call this in our update. So in our update method, we can ask if is touched. We grab the player's x, player's y, player's width, and player's height. That's the rectangular area that we're detecting, whether or not it's touched. And we're simply just going to, instead of the effect playing here, we'll cut that, and we'll have the effect play here, just so we know. So if we test this now, if you see, I'll be touching in random places, nothing will happen. However, if I touch on the blue rectangle, then we get our sound effect. However, if I touch anywhere else, then I will not. The next video, we're going to be looking at rendering custom fonts in our Libgdx game. We're now going to learn how to use custom fonts in our Libgdx game. We're going to take a look at bitmap fonts and how we can also use free type font to use custom fonts and convert them into a bitmap font. As you can see, I have this random font in TTF format that I'm ready to copy and paste into my assets folder. We're now going to create our bitmap font object. That's going to be called bitmap font. However, our font is in TTF, not bitmap format, and so we need to convert this. To do this, we're going to create two different things, and the first thing is the free type font generator, and we're just going to call this generator, and that's going to be equal to a new free type font generator, and it's going to take an internal file handle, which, as you can probably guess, will be font.ttf. We also need a free type font parameter, and this is basically going to set the parameters for our font, and this is going to be equal to new free type font parameter. So let's just set some parameters for our font. I think size is a pretty common one. We're going to have this equal to, you know what, I don't even know what a suitable size would be. I guess 16 maybe. Color, not blue, red. I think red is satisfactory. Yep. And most importantly, we need to flip this, just like we have been doing with all our assets. And then finally, our bitmap fonts can equal our generator dot generate font, and it'll take in this parameter. Just to make sure our font is all smooth and stuff, our font dot get region dot get texture is going to have a filter of texture filter dot linear, and that should be everything. Of course, we need to actually render it on the screen. We actually need a sprite batch for this, so go ahead and just up here create a sprite batch. And you know the process here, nothing too technical. And then down here, sprite batch dot set projection matrix, camera combined, and then we have our sprite batch begin and sprite batch end. We're now going to take our font and draw. It's going to take in our sprite batch. It's then going to take in our score, which we haven't made yet. So what we actually do need to do is we need to take a string value of, because it's going to be stored as an integer, string value of score, and we'll get that in a minute, and we'll have this rendering at 0, 0. So let's go ahead and make that score integer. I'll just put it along with all the other integers, score, and the initial value is going to be equal to 0. And down here, where we're detecting this touch, along with that play effect, we're going to increment the score by 1 each time. Now, obviously 16 was very, very small, so we're going to go ahead and change that. And as you can see now, if I touch, then my score gets incremented. Now, the reason it's actually detecting multiple clicks is that it's actually detecting for holds as well. So it can just spam out like that. The best way to get past this is to just simply, after the score and effect have been played, just do a thread sleep for about a second. And we have to wrap this in a try catch loop. And then we can play our game again. Now if you'll see, it works perfectly fine. The sound effects isn't spamming out, and our score is only updating incrementally. In the next video, we're going to be looking at saving data. In this video, we're going to be looking at how to save data in our Libgdx game. We're going to take a look at the Libgdx preferences and also the Android shared preferences. So we're going to create a preferences instance in our gameplay screen. So just simply go ahead and create a new preferences, and we're just going to call it, first import it, and we're going to call it data. and then go ahead and initialize this. So we'll do it up here. Data equals gdx.app.getPreferences. And we're going to name this, it really doesn't matter, our data. If there is an instance of this preference, then it will essentially read it. If not, it will then create it and then read it. So now what we want to do is, every time that our score increments by 1, we want that to be saving periodically to our game. And all it is one very simple line of code. So if we just go down here into our update method, when the score is incremented, go ahead and in our data, go ahead and put an integer in there. And the key can be anything we like, and we're going to call this score. And the value is going to be score. And that's it. We've now saved that piece of data. And now whenever we want to load that piece of data, all we now have to do is set the score equal to our data dot get integer with the key score. If there isn't one, then you can see we're being asked for a default value, and that is 0. One last very simple line that we do have to write in is data.flush. And that essentially just means, okay, everything that you've put in, go ahead and write this. And all this is being saved to the Android Shared Preferences class. This allows for your data to be survived through updates. However, as soon as you uninstall the app, then yes, your data will be cleared. Now if you see, we have our score increasing, we have it as 2. If I now then quit this game, and then I go ahead and open it up again, and as you can see, my score resumes from that 2 position. In the next video, we're going to be looking at how to use the vibrator and the accelerometer in our Libgdx game. We're going to be taking a look at the physical world in this video. We're going to take a look at using vibration and integrating that into our Libgdx game, and then also using accelerometer and gyroscope in our game. So in order to add vibration to our game, we first need to actually get the permission from the Android manifest. So go ahead and hop into your Android folder, go into manifests, and then the Android manifest. And here we want to write in users permission. We want android.permission.vibrate. Now gameplay screen, we can then go ahead and when we touch our player, we can, along with the score incrementing and the effect playing, we can also gdx.input.vibrate, and then you can set how long you want the vibration to go on for. So just a short, I think half-second vibration would be fine. Now obviously I can't exactly show you this with the emulator, so I'm just going to carry on. You can also make some pretty sophisticated patterns as well by using an array. So if you go ahead and write gdx.input.vibrate, you can see that you have another option for this method, which is a pattern using a long array, and whether or not you want it to repeat as well. So you could go ahead and write a new long, and then in here you could have it vibrate for 500 milliseconds, pause, then again for maybe 200, then pause, then 100. And you can have this repeat maybe 5 times. Or if you want, not repeat at all. But we'll just stick to this. Next thing we want to do is make sure that the user is only playing in portrait. We don't want them flipping the phone sideways and then maybe, I don't know, getting some sort of competitive edge. So let's just assume that that is the scenario. We can actually go about doing this. First, we can ask if the accelerometer is available. So if we go down here, and in this is touch method, before we check for this touch, we want to check if the device is in the proper orientation. So first we're going to check if gdx.input.isPeripheral available, peripheral.accelerometer. And then we can query the current orientation by getting gdx.input.getRotation. And this will return a value of either 0, portrait, 90, landscape right, 180, completely upside down, or 270, landscape left. So if that is the case, and rotation is 0, and if touch is true to this, then we can go ahead and run all of this code. You can also query the accelerometer for the X, Z, and Y rotation by simply asking gdx input.get accelerometer X, Y, and Z. Welcome to section the third dimension. In this section, we're going to take a look at an introduction to 3D and how we would go about rendering in 3D in Libgdx, and then looking at 3D lighting models, and then looking at 3D lighting and how to incorporate that into our game, and then looking at 3D lighting in Libgdx, and then using Blender to import 3D models into our Libgdx game. We're now going to take a look at incorporating 3D into our Libgdx game. In this video, we're going to take a look at the very basics of 3D rendering in Libgdx using a completely different camera. So as you can see, I've reset my gameplay screen completely, and I've deleted the main menu screen. This is because now that we're going into 3D, pretty much everything is going to be different, so we may as well just start from scratch. And I've also taken out the main menu screen out of the main class as well. So the first things first is to create our camera. And we're not going to be using the orthographic camera, we are going to be using a perspective camera. And let's just name this camera. We're going to set this camera equal to a new perspective camera. And we have three parameters here. We have a field of view, a width, and a height. Field of view is generally about 67, so we'll go ahead and put that. And that's if we're running a landscape game. We are going to change our Android manifest to landscape, so go in there and change the orientation to landscape. And that's a typical landscape field of view. You can of course adjust that to what you like, or even have an option in your game, but for now we'll just set 67. Now, because this isn't an orthographic camera, this isn't one of those that scales, we're just going to set this camera equal to whatever the screen size is. So gdx.graphics.getWidth, and gdx.graphics.getHeight. And the camera position set needs to provide an X, Y, and Z. We're going to have this as 10F, 10F, and 10F. I'll tell you the reason in a second. We also need a camera.lookAt. So think of this camera as a physical camera in a 3D space, like if I had a camera on you in real life. And we're going to look at the origin, 0, 0, 0, 0. Now, the reason why this isn't 0000 is because if I'm looking at 000, how can I also be in 0000? So this essentially just offsets the camera up, behind, and left by these values, or sorry, down, and it will then look at this position. We also need a minimum and a max render distance, so how much are we actually going to be rendering, and the defaults Libgdx gives is 1F for near and 300F for far, but of course these are adjustable throughout the game development process, and again these can be toggleable options as well. Now we actually need, like a sprite batch, something to render things, and this is going to be a model batch. We'll just call this, no, we'll call it batch, we'll just call it batch. And this is going to render models on the screen, if you couldn't guess already. This batch is going to be equal to new model batch. Now, as a result, we also need, as you can guess, a model. Call this model, but also a model instance. Now the difference is that a model, we'll call this model instance, actually, we might get, it's a bit confusing. Now the difference between model and a model instance is that a model contains the graphical properties of the actual model itself. However, the model instance contains things like the scale, the rotation, and the position of the model. So for example, if I had a zombie type, then I would define the model as a zombie, but then I want the player to be attacked by 5 zombies, so I would have 5 zombie instances. The model is essentially the template, and the model instance is the actual thing. And before we actually start to define this, make sure you dispose this model down here in your dispose method. Now for actually defining this model, first we need a model builder. So just go ahead, and this is going to be very temporary, that's why we're just putting it here in the constructor, equals new model builder. And so our model is going to, from the model builder, create a box. And as you can see, we have a lot of options here. It's pretty nice, but we just need a box. So create a box, and we have 3 different parameters. Width, height, depth, material, and attributes. Width, height, and depth are pretty self-explanatory. We're just going to go with, I don't know, 4F for now. For each. We want a perfect cube. We've then got material. We're going to have new material. Color attribute, not color. Color attribute. As you can see, this comes from the com.badlogic.gdx.graphics.g3d attributes. So color attribute. Create diffuse. And as you can see, you do have these different color creations for the material. I don't really know how to describe this, but color creations, I guess. And we're just going to have this color, I don't know, oh, blue, because our player was blue in our 2D game as well, so how about blue here as well. And the next one, as you can see, is attributes. This is plural. We're just going to make this on a separate line because it's getting quite long now. This is plural, so we can have multiple. And one of them is going to be usage.position. And this essentially says that our model has to have a position when we make it. When we create a model instance, it's going to have a position. And also, we want a usage.normal. This just makes sure that, you know, generic things like lighting and stuff like that just works fine. And then we're going to finally create our model instance out of this model. Just simply model instance model. In our render method, we're going to set the gdxgl.gl viewport to 0, 0, gdx.graphics.getWidth and gdxgraphics.getHeight. This is essentially the canvas, and we want the canvas to start from 0, 0 and have a width and a height. And in 3D, no, Libgdx does not have that weird, you know, Y is flipped thing, so you don't have to worry about that. And like with 2D, we have this method that we don't really need to be concerned with, but we have it nonetheless. gl.colorBufferBit, but also gl20.gl depth buffer bit, because we do have depth now. And just simply batch.begin, and we need to intake this camera, and batch.end, like we've always had it. Before that, actually, camera.update. And we can now render our instance. Batch.render instance. If we go ahead and play, and as you can see, we do have our cube. We can't really tell it's a cube, it's more of a, how do I put this, mangled hexagon, and that's because we don't have any lighting. In the next video, we're going to be looking at 3D lighting. In this video, I'm going to take you through how to incorporate 3D lighting into your Libgdx game. We're going to take a look at implementing an environment into our game, and then as a result, implementing basic directional lighting into our game. So to add our lighting, we first need to create an environment. To do that, go ahead and define an environment up here. Environment. I always struggle to spell that. And then over here, go ahead and environment equals new environment. And the environment set dot set. We're going to give this a new color attribute of not a color, but a color attribute of our own ambient light. And this ambient light is going to be 0.4f, 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 and 1f. And you can play around with these values. And then environment.add, we're going to add a light, a new directional light. And we're going to set this directional light to 0.8f, 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 0.8f. That's the color. And then a direction of, I don't know, not so far out the center, but maybe 1f, minus 1f, minus 0.8f, and minus 0.2f. The best thing really to do with the environment is to just play around with the values. Why isn't that working? I added one too many 0.8fs. There we go. And just honestly, just play around with these values. They're very tricky and nitpicky to get right. So just, yeah, that's the best advice I can actually give you. So all we have to do then is add this to our render. we're going to render the model instance under our environment. Go ahead and run that. And our cube now has a little bit of lighting. If we increase the intensity of this ambient light to 0.8, you can see that the lighting is less prominent. That's because it's really shining as much as it can. So our 0.4F values were pretty good, but maybe 0.2F might be the sweet spot. There you go, our colors are more saturated, but they are more clear and prominent. So 0.4F probably was the best values to go with in the first place. But again, that always depends on your game. In the next video, we're going to be looking at importing 3D models into our Libgdx game. We're now going to have a look at importing 3D models into our Libgdx game. In this video, I'm going to take a look at downloading Blender and learning the basics of it, and then exporting a model to then import into our Libgdx game. So to create a 3D model, we need to use some 3D modeling software. And the best free modeling software out there, undisputedly, is Blender. Most people would agree. So go ahead and go to blender.org and download Blender. We want Windows, 64-bit, and doesn't matter where we download it from. Netherlands is probably the closest to me, so I'm just going to get it from there. Once it's finished downloading, go ahead and click on the installer. Hit next, next, and install. It's a pretty straightforward installation overall. Once it's finished, go ahead and open it up. And just click anywhere to get rid of that. And go into full screen. Now by default, we do have a cube. And now I'm no Blender expert, so if you do want to get more into this, I'd suggest going elsewhere and looking for some Blender videos, but I will give you a very, very brief run through. As you can see here, we have our separate axes and arrows for them. If we drag on those, then the cube moves along. As you can also see, we have this translate window that pops up in the bottom left, and here we can set absolute values for the translation of our cube. We can also hit the S key and move our mouse to go ahead and scale this. And once we've done that, we get this resize as well. And we can go ahead and once again set absolute values for the size of our cube. Under the Create panel, we do actually have a lot more options, but we're just going to stick to our cube for now. We are, however, going to add a texture to our cube and turn this into a dice. Because it's a basic video, I'm only going to make this a dice with just one on all sides, so not very inspiring, but hey. But even one texture on Blender is a bit of a pain to apply. So to do this, go ahead and click this little icon on the very far right, and click here, and here is where we're going to add on new texture. And the type is an image or movie. From here, go ahead and open an image, and I have my little red die over here. And there it is in the preview. We then need to go ahead and change our view. So if you go up here where it says default, go ahead and click that and change this to UV editing. Then open up that image texture we just created. Now on the right hand panel underneath, go ahead and click from object mode to edit mode. And from here, everything is selected. If it isn't, go ahead and press A. Then press U and unwrap. We can then go ahead and go back to the original view. Then right here at the bottom, beside edit mode, go ahead and click that and click texture. And there we go, we have our texture rendered on our cube. Now we need to go ahead and go into File, Export, and we need to export as a wavefront, so a .obj, and that's what Libgdx takes. I'm just going to save this as dice.obj and export. And once that's done, I'm going to close out Blender and go back to Android Studio. In Android Studio, I'm going to go ahead and copy both of these files I've exported and the original texture. Copy them to my assets folder, yep. And I'm going to open up this dice.mtl. And just make sure that that file name or file path is the exact same as the one here. So this file path may be, I don't know, c/downloads/whatever. You need to make sure that's completely clear and all that's present is the file name. I'm just going to rename this to dice, and same here, because that is an extremely common error that people run into. Once we've done that, it's very simple to go ahead and render this to the screen. Right here, all we need to do is change this model builder to a model loader. And this will equal new object loader. And then the model is simply going to equal loader.loadModel gdx.files.internal. I don't know how it's not stuck in my head already. And we're going to take this dice.obj. So dice.obj. And that should be all. And there we go, we have our little dice object. It's a little bit smaller than our cube from the previous video, but in Blender we can go ahead and double the scale or do whatnot with it.